I'm Ralph Bagnall, and welcome to the first episode of Woodcademy TV. We're all aware that woodworking is inherently dangerous. You can get injured doing it if you're not careful. That's why you need to read, understand, and follow the rules in the manuals that come with your tools. And as important as the safety glasses are that you put over your ears, and the hearing protection is that you use in your ears, it's what's between your ears that is your best safety device. You are your own best protection. And our first project is going to be this attractive breakfast tray, based on one of the ones used in the popular PBS TV show Downton Abbey. It's an attractive and useful piece and has some nice details that can help you learn new skills along the way, like angled finger joints where the rail parts meet, and a wooden spring that is designed to both lock the legs open by simply unfolding them, but also holds them in the closed position once it's folded up. Pretty easy to make, but a very attractive gift or piece to use around your own home. In this first of 2 episodes, we're going to cover stock choice and preparation, gluing up the panel that will become the tray body itself, prepping the stock for all the other pieces, turning the legs, and forming both the side rails with the handles and the stretchers that go between the legs. In the second episode, we'll assemble the tray, put together the spring mechanism, and then finish it. So let's get started. Now, the key to building furniture projects that will span generations is choosing and preparing your stock carefully. It's usually best if you can choose your own stock at the lumber yard. You want to choose stock that has minimal defects, is straight and true, and has a tight and pleasing grain pattern. It can be difficult with rough lumber to know exactly what the wood underneath the surface is going to look like. Don't be afraid to bring a small block plane with you. You always want to ask permission first, but a good lumber yard should allow you to at least uncover a little bit of the material to see what you're buying. Another advantage to this project is that none of the pieces are more than 22 inches long. So you may be able to buy shorts and leftover pieces from your lumber yard, which usually come at a discount. Except for the parts that you're going to glue up into your tray, none of the pieces in this project need to be more than 2 inches wide. Again, helping you buy your lumber a little more inexpensively. And I made mine out of pieces that are 5 inches wide, nominal 6-inch stock, which is fairly common and again, isn't going to break the bank when you go to buy it. The tray can be glued up out of narrower pieces, but the narrower the pieces, the more you're going to need, and the more difficult it becomes to get an even grain pattern and tone across this relatively wide surface. So ideally, 3 pieces 5 inches wide will give you a 15-inch wide blank, which then gets cut down to 14. That's about the ideal preparation for this. Now, the only thick part on any of this are the legs, which end up at 1 1/8 thick. 5/4 stock should nominally be about 1 1/4 thick, which should give you enough room to joint and plane these pieces down to 1 1/8 and leave them clean. Again, they're only 8.5 inches long. You'll probably need to cut your stock 10 to 12 inches to go through your planer, but it's relatively easy to get the pieces you need. If you have to buy thicker stock, then you can. But the 5/4 stock will allow you to resaw into 2 pieces that are roughly 1/2 inch thick so that you can plane it down to the 3/8 that the rest of the parts for this project typically end up. The other two exceptions to the 3/8 inch rule are the spring block underneath here, which will be 3/4 and is only basically 2 inches square, so it'll be a piece of the scrap and leftover. And then the spring itself actually gets planed down to 1/4 of an inch to give it the flexibility that it needs to act as the spring. So let's do some quick math, and I'll show you how to figure out exactly how much stock you need to build one of these trays. All right, so now I'm going to show you how I figure out how much lumber I need, how much it's going to cost me, and what board footage actually means. Now, I prefer to draw out what I need. So I'm going to need a couple of sections of 24-inch pieces, because the basic building block on this is 22 inches long. And those are going to be 6 inches wide, nominally 6 inches. You're going to buy 6 inches, whether it's 5 3/4 or 5 1/2, because that's the way lumber is sold. So it's going to be a nominally 6 inch wide board. Now I need 2 feet for 2 of the pieces. Remember, we're going to split these in half. So 2 of my tray bottoms or tray parts are going to come out of one of these, 1 tray part out of the other. I'll be able to get 2 of my rails or my spring or my stretchers, and then the rest can come out of the last board, and that gives me a little bit of extra. When I split all of these, I'm going to choose the 3 closest matching pieces to make the tray part out of, because they're the glue up that's involved here. Now for the legs, I'm also going to need another 12 inches. I only need 8 1/2, but cut it to 12 so that you don't have to worry about joining it and planing it. You'll have room to use your machines. So there's another 12 inches there. So this is a total of 7 lineal feet of a 5/4 by 6 inch board. 7 lineal feet. But that's not 7 board feet. A board foot is 144 cubic inches. And that's represented by a piece that's 12 inches long, 12 inches wide, and 1 inch thick for 144 cubic inches. That's a board foot. Now in this case, it's half of that because we're only buying 6 inch material, but it's 1 1/4, 5/4 material. So we need to multiply our 7 lineal feet by 1.25, which is going to give us, in reality, 8 3/4 board feet. But then we're going to divide that in half because it's 7 lineal feet of 6, so it's 4 3/8, call it 4 1/2 board feet. Now chances are you're not going to find 7 lineal foot pieces. They're going to typically be 8. So an 8-foot, 5/4 by 6 inch wide board is going to be roughly 5 board feet. And that gives us a little bit of extra to work for. So your cost is going to be 5 board feet of whatever material you're buying. And this is a very common size, the 5/4 by 6, so it should be fairly easy to find and it should be relatively cheap. So for each piece that you want to make, each tray that you want to make, you're going to buy one 8-foot, 6 inch wide, 5/4 board of about 5 board feet for each tray you want to make. Begin by cross-cutting your plank into the sections we just discussed. Resaw the 24-inch sections, splitting them right down the middle. And here's my pro tip to you on stock preparation. I do mine twice. The first time, I face joint, I plane to thickness, I rip to width, I get close, but I don't finish at the final dimension. This piece, which will become one of the pieces of the tray, is a little bit thicker than the 3/8 I wanted to finish up at, and it's a little bit wider than the approximately 5 inches I want it when I glue this up. Even when it's properly dried, the wood that you're working with always has a certain amount of natural stresses built into the wood. Could be that the tree was growing on a hillside or in a windy location, and even the growth rings and the orientation of the rings within your parts will, especially when you resaw them, as we've done here, can cause your material to change shape, to relax out, to release some of that stress when you've either removed a lot of material or, in this case, resawed it. And so in order to let that relax out and then remove that movement after it's done and ensure a square true project that will stay flat, I mill twice. Once this has had a chance to relax out, I'll take it back to the jointer. I'll start with face jointing. I'll plane to final thickness. I'll joint the edges. I'll rip them to final width, just as if they were rough stock that I was starting with. But this two-stage process means that there are very few surprises down the road after my project is built and completed. Then once the parts are pre-milled and have had a chance to settle, they get processed to final dimension in the normal fashion. All right, so now I've got my boards all jointed so that they go together well. I've cut away as many defects as I can. They're pretty much ready to glue up now, but I want to make sure that whatever I'm doing, everything stays in the right order. So I can just mark the boards with a little delta. Now this shows me not only which faces go together, but also where they go together end to end. And this way, I can always get these boards back into the orientation that I set up now. You'll notice that here I'm actually gluing up 4 pieces to form the tray. Between the prototyping and the filming of the show, I made up a couple of these trays. Look closely, and you'll also notice that these parts are actually being joined with a V-groove edge rather than a butt joint. It's an option that I sometimes use with thin panels, and is discussed in the PDF plans that you can purchase for this project. Here's a couple of things to bear in mind when turning your legs. Because we're starting with the top being square and we're only turning the lower section, the blank has to be 1 1/8 inches square. So that means that when you mark the centers for your lathe, you have to be pretty accurate, because otherwise the round turning is going to be slightly off center from the square turning. Normally, you start with a blank that's a little oversized, you round the whole thing, and life is good. But we can't do that here. We have to be much more accurate when we set our center points in the lathe. The second issue is that as we turn this section round, we want these corners to stay square and true. We don't want them to break away, which they're going to do if we try to do this just by turning. And so we're going to kerf these 4 corners to prevent any tear out from extending into the square area. And it's not difficult to do. I've marked the 4 sides where the transition is, and I'm just going to carefully kerf the corners at that mark. Not terribly deep, just enough to prevent the tear out. And that's going to allow me to round the lower section without actually breaking into the upper part. Now I'm going to carefully bring my square tool in and transition that corner. Need to go a little bit closer in, but you can see that there's no tear out in the corners. Now I've made quite a few of these legs already in the process of creating this piece, so I figured out an easy way to make the legs. The leg is created from 3 basic sections, which I've laid out here. I'll turn this section, using my template, to 1 inch in diameter. The second section gets turned to 13/16 in diameter, and the third section, where the foot is, gets turned down to 3/4. Once those are stepped off, then we can put in the details. So now that I've got the 3 sections turned, it's time to transfer the details to my part. And I'm going to do this using my story stick. To start with, this is where the high section of the bow is going to be on this part and here. Those areas really don't get turned any further. We're going to taper from these downward. There's a single bead at the top, which extends from here to there. So I'm going to mark that. Then down below the first transition here, there's a double bead. And so I'm going to mark the center point between the 2 beads here, and then the outside of the bead there. So I'm going to create the beads running from there to there. And then on the foot, the high spot is going to be just after the transition. It's going to come up fairly sharp and then taper down to 3/8 at the bottom. So all the information is here on my story stick to recreate all the details. Now you can tackle these in any way you want to, but the only really tricky part is this first bead. In order to form the bead, I need to cut a groove deep down to about 3/4 of an inch in diameter, right in here next to my square transition. Got to be very careful not to impact that square transition, or else I can tear it out. Now I can work down the leg, filling in the details as I go. I'm certainly no expert turner, but I find it easier to work from the high spots down to the low. While you're working, keep in mind that it's far less important that the legs exactly match the pattern than that they match each other. And if you don't have a lathe, that doesn't mean you can't make this project. Many antique examples that I've seen of this type of tray do feature square, tapered legs. And I've included a measured drawing of such a leg in the project plans. Well, that looks great. Now just 3 more to do. The tray blank can now be sanded. I do most of the sanding before cutting it to size. Heavy sanding can sometimes round the edges a little bit. So by sanding first, that gets trimmed off. One long edge gets jointed and the top ripped to 14 inches wide. The blank is then cross-cut to 22 inches wide. If your saw can't cross-cut 14 inches using the miter gauge, a circular saw does just fine. Laying out the notch that's in the front of the tray is easier than it looks. Scribe a line across the front 1 inch in from the edge. Then mark this line at 3 and 5 inches in from each end. These marks are the center point for your compass to scribe 1 inch radius arcs that form the sides of the notch. A straight line connects the 2 inside arches 2 inches in from the edge. This top was made in cherry, so you could see the process a little more clearly. The top is carefully rough cut as close to the lines as possible, and then sanded smooth and clean, finishing at the lines. Now the gallery rail that runs across the sides of the tray and form the handle, and across the back of the tray, the sides and the back are both set at a 15-degree angle, which means that the finger joint between the sides and the rail in the back are also at a 15-degree angle. Looks like a complicated joint, but it's really not. And I'll walk you through it. The only extra step in making the angled finger joint is to cut the ends of the parts where they're going to join at a 15-degree angle. The rear rail is cut on both ends, and the sides are each cut only on the back end. Now the back is only going to be 1 9/16 tall. At this point, we're going to bevel the back edge, and as it sits at that 15-degree angle, that's going to make it 1.5 inches tall. But the sides, they're going to be 1.5 inches tall where they meet the back, but then they have to widen out in order to accept the hand grips that we're going to put in to hold the tray with. It's just a lot easier overall if we make all the pieces the full width first, the 2.5 inches, do our finger joints at the angle, and then trim everything to the proper final dimensions after we're done. So let's go ahead and do that. I've got a 1/4 inch dado stack set up in my table saw. I've got my 1/4 inch box joint jig all set up. I've already cut a test piece. We're ready to go. Now we can just cut these pieces. The first set of fingers are cut into the ends of the back and are done exactly the same way that you would do a standard finger joint. Index against the pin, and then index using the pin working across your part. These ends are then reversed onto the jig, so they will index the first cut on the mating part, just as with a standard finger joint. But the two parts are only in contact at a small point at the very bottom, and this point of contact is removed during the first cut. So be careful that the side piece does not move until after the cut is completed. After that, it's simply indexed and cut as any finger joint would be. The saw is still set to 90 degrees. The only difference is the angles on the ends of the parts. You will need a couple of templates to shape the sides of the rails and the stretchers between the legs. So let's make those now. A printable template is included with the plans. Print them at full scale and adhere them to a piece of 1/2 inch plywood. Then rough them out. The opening for the handle in the side template will need to be drilled out, and the template sanded to the lines both inside and out. Always take your time and work carefully when making templates. Any errors in the templates will be repeated on your parts. All the curves are done on the drum sander. For the square and angled ends, I used a sanding disc with a miter gauge, ensuring that the angles were what I wanted. Now here's a pro tip you're not going to get just anywhere. When you're using a template like I am here to mill, in this case, this is the stretchers between the legs on our project. The problem is that the grain direction of your part can run into problems when you're flush trimming. So as I start here and work my way down, the grain is coming this way, and I'll be cutting away from it with the cutter moving this way, so it's going to work out just fine. But as I come back up this slope here, there's a possibility, because the grain runs this way, and here you can see it's actually running just a whisker downhill, I can end up pulling that and tearing it off. So I'm going to cut this here, down here, and I'm going to leave behind these 3 areas where there's possibility of tear out. Then I can flip the piece over Now my bearing is going to ride on the template, which is underneath, so now I can come in and finish up this part, and here, and here, and here. I can finish these other parts. Now if you don't happen to have a bearing bit like this, or a flush trim bit with the bearing on both sides, you do always have the option of using 2 different bits as shown here. So here we've got a bit with the bearing on top. Here we've got a bit with the bearing on bottom. It's known as a pattern bit. So you can swap bits and get the same results. The template is attached to the side blank. Make sure the back of the template is flush with the finger joints and that the bottom is flush. The rest will get trimmed away. Rough cut the blank to the template, but leave about 1/8 of an inch for flush trimming. And you'll need to drill the waste in the center of the handle. But again, be careful to leave enough to trim. Now the part is ready for flush trimming. The inside of the handle gets flush trimmed first. No need for any fancy tricks here, just make sure you get it all smooth. Notice that I'm using a start pin. This is a great help when starting the cut to keep the bit from grabbing the part and possibly tearing. Again, I'm cutting just the parts where the grain is favorable, and then I'll flip the whole piece over and cut the rest. Flush trim both the sides and the 2 leg stretchers while you've got everything set up. All 3 rail parts need the bottom edge jointed to a 15-degree angle in order to sit flat on the tray top. Set for a shallow cut and make the same number of passes on each piece until the bottom is completely beveled. The back of the shaped side part is used to set the fence for ripping the rear rail down to its final width. This ensures that all 3 parts will line up when you go to assemble them. Finally, using a 1/8 inch radius bit, round over both top edges of all 3 rail pieces, including the handholds, the shaped bottom edges of both stretchers, skipping the center notch, and the entire perimeter of the tray body itself. All of the components except the spring assembly are now completed, and we're ready to move on to doing the sub-assemblies, which we'll do in episode 2. Now, if you'd like to build this project for yourself, a complete set of plans is available for free on our homepage. It includes measured drawings, photographs, material lists, everything you need to make your own version.